Let's do some more examples of computing definite integrals using just the fundamental theorem of calculus. So here we have a definite integral from 2 to 3, 4x squared plus 3 over x squared dx. How do we do it? Well, again, the first thing we do is find an antiderivative. So let's do that. So the antiderivative of x squared is x cubed over 3. I carry the 4 along. The antiderivative of 3 over x squared, well, 3 over x squared is the same as 3 times x to the minus 2. So the antiderivative there is going to be increase the exponent by 1, so add 1 to the exponent, and then divide by the new exponent, so divide by minus 1. Okay, so that's what I'll write here. So this will be 3 times x to the minus 1, but with a minus 1, and so the minus 1 could go actually up front, so that could go minus 1 there. So that's an antiderivative for 3 over x squared. And then I write this bar, and the bar reminds me that I have to, since this is a definite integral, I have to put in the two endpoints into this function and subtract. So I'm going to put in the 3 first, top first, so I get 4 times 3 cubed over 3, minus, then put 3 in here, so I get 3 times 3 to the minus 1, or 1/3. Okay, so that's the first part, that's f of b, capital F of b, minus, and now I have to plug in the 2. So I use a parenthesis first, so 2, I have 4 times 2 cubed over 3 minus 3 times, and then 2 goes in for x here, so I get 2 to the minus 1, parenthesis. Don't forget these parentheses. Okay, so let's evaluate that. So that's the same as, well, 3 cubed over 3, I get rid of a 3, so that's the same as 3 squared, so that's the same as 9. Minus, and then 3 divided by 3, 3 inverse is the same as 1/3. So 3 divided by 3 is just 1, right? And then 2 cubed is the same as 8, so I get 4 times 8 over 3 there, minus, and then 2 to the minus 1 is the same as 1/2, so that's 3 over 2. Okay, so that's my integral so far, and then you can simplify this. This 36 minus 1 will be, it's all arithmetic from here, 35, and then this will be the same as 32 divided by 3. And if you want to get rid of the parenthesis, then this minus goes with that minus to make a plus, so I get 3/2. Okay, and then you can simplify using arithmetic. Okay, but that's the basic idea. We first found an antiderivative. We write this bar with the upper limit and the lower limit, then we plug in the upper limit into our antiderivative, the lower limit into our antiderivative, take the difference. That's it. Let's do another example. Here we're going to compute the antiderivative, the definite integral from 1 to 3 of x to the minus 1 plus e to the x. We find an antiderivative, so the antiderivative x to the minus 1, well, you might use the power rule, but you'll find that, in fact, this should be ln of x, right? It's a minus 1 power, so ln of x, plus the antiderivative e to the x is e to the x, right? And so then, after doing that, I put my little bar here with my 1 to 3, which reminds me that I have to plug in 3. So I have ln of 3 plus e to the 3. So that's the first part, that's with the 3. And then I subtract, don't forget your parenthesis, where I plug in 1. So ln of 1 minus, or plus, this plus is plus e to the 1. Right. So I have this, and so that's going to be the same as ln of 3. I can't do much about that. And then e cubed is e cubed. And then minus, and then ln of 1 is 0 plus e to the 1. Okay, but this minus goes on e to the 1 also. So I have ln of 3 plus e to the 3 minus e to the 1. Okay, now you could put this in your calculator, but that would only give you an approximation. The actual answer on the exam might be this. So if you put this into your calculator and you get some number, blah, 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 it may not be the right thing. It will be an approximation. The better answer is the exact answer, where you don't evaluate these numbers in your calculator. You leave them blank. If it's a multiple choice problem, this is what you may see.